But without further delay, really happy to have VICTORERIC here and two folks here, Eric Lee, Principal and Design Director, and Joe Gerl, Senior Building Design Technologist. And basically the theme of the presentation is what it takes to build a high-performance home with maybe 2 or 3 feature projects in there. And I had the great pleasure of seeing one of their projects in Terra Nova, part of City of Richmond, on a kind of industry site visit that they opened up the doors in a 3/4 way through construction mode to have a look at that high-performance home. So it's pretty impressive, and I'm looking forward to the presentation. Take it away, Eric and Joe.
Yeah, so first I want to say thank you to City of Richmond for putting this on, very valuable, and Ener and Rob for sharing your information. So a bit about us, we're a integrated design build firm, established in 1997. We've done lots of projects here. I'm the owner and Joe is my senior building technologist. And by the way, I'm also a certified pass house designer, so coming from a lot of training experience from that perspective. Now, our goal today is to really speak on the building side of things and give people the reasons why they want to be considering building high performance homes. And then we'll dive into some case studies and give you some keys to building high performance, because this is overall a fairly new thing for a lot of builders. So we want to be giving you reasons why to do it, and then also some keys to success. So construction-wise, you know, it's very simple. Better construction equals a better brand. So if you're a builder out there, you want to be building up your brand, because brand equals trust, right? And then also less warranties and callbacks. High performance means quality. So that means less warranty, less headaches for you guys, and less callbacks from clients. Number 2, it's a mandated code requirement. You've heard it here. Ener's talked about it. Cities in Lower Mainland will be at step 4 or 5 by 2025. And that's really only, you know, 3.5 years away or something like that. Richmond will be at step 4 by 2022. Okay, that's in a year and a half. So the smart builders are really positioning themselves ahead of the curve. And the benefit of that is, if you do it now rather than waiting for the last minute, you get time to trial and error. You get time to work out these kinks with your trades, with your process, with your systems. And then a final thing would be that your customers are getting already educated right now, you know, by Haven, by BC Housing, BC Hydro, city initiatives. They all have initiatives to educate the public. So if someone comes to you and asks you, hey, I want to build a high performance home, I want to get to step 4, step 5, you as the expert should really be up to bat with that and knowledgeable with that. And then 3 really is to reduce the carbon footprint. You know, whether you're about the environmental side of things or just reducing energy, high performance and passive houses are known to reduce energy by up to 90%. So high performance homes last longer also, which means ultimately less waste for the landfill, right? If you think about how we built in the 70s, 80s, 90s, it doesn't last as long as what high performance will do, which means that we put less waste into the landfill. And now with all the recycling requirements, you know how much stuff is going in there, and we're trying to plan that curve. High performance homes are much easier to get to net zero. Once you get to high performance, you've reduced your energy consumption by a lot already, so it just takes a little bit more to get to net zero. Then some keys to success for building high performance homes. One, first and foremost, it's a mindset shift. Ener's presentation was very good in talking about that. That whole process of building and designing has to completely change. How you think about designing, getting some plans, going to city, and then you, the builder, going to build it, it's very segmented and it can't work like that. So the traditional process no longer works. For high performance, it's performance-based, so you really have to be looking at how to integrate earlier with the design and the consultant team, whether that's your energy advisor, your mechanical consultant if you have one, and the designer, obviously. That all has to be integrated. So number 2 is where I talk about that. Because it's a performance-based and no longer prescriptive-based, the burden of proof of performance is now on the design and construction team, right? So you have to prove that it performs. And therefore, the step code, building step code and building high performance requires a tighter coordination with the design team early on in the process. Inner's slide with that curve, the two curves about cost control and options and such, that's a very good example that there's a point of no return at a point in the process that you just have to make those decisions early on. 3, tight supervision of envelope trades. That's super important. Step code high performance is very much about the envelope. There's a mechanical component, but there's a lot of it on the envelope side of it. So as the builder, you now need to be that master conductor to a symphony, right? And your trades are the symphony. So you being the master conductor leading the whole symphony, you need to know more and be more knowledgeable than the trades. The old way of just letting your trades do things, let the plumber go in and punch vents through the roof, and then your window guys, and you just being the person that is just on the sidelines, that doesn't work anymore. You have to know enough about the trades, because what's happening is if one trade does one thing, like let's say punctures your plywood for a conduit that they need, you need to understand that there's ramifications there, and then bring the air barrier or the paper people back to tape that up. So there's a lot of components that have to work in symphony to balance out and really give that high performance air barrier that is needed for a step code home. 4, have a very good understanding of air barrier. We're going to talk a lot about that. Inner's talked about that. It's just so critical. So the air barrier is the most important aspect of step code success. And you as a builder need to not only understand, but also advocate for tight air barrier. There's still a lot of people used to the old ways and really doubting that, what if you made it too airtight? Those myths have to be busted, and you need to really understand that. And we're going to give you a bit of information about that, but we'll leave you with more resources to find out on your own there.
Yeah, so I guess there is a relationship between the designer and the builder. The builder is the conductor, and the designer is the composer. And as a builder, you can't really be writing the music while you're conducting the orchestra. So you do have enough to worry about on site with coordinating trades and making sure people are doing what they're doing and not damaging the integrity of the project. So it's really not up to you to be specifying things that maybe the designer has missed. So it's important to really establish that two-way communication with your design team. Ask questions and ask for details for things that you're really not aware of or things that have been missed. So, as has been discussed, the prescriptive code is kind of done away with now, and there's now the performance-based aspect of the code. And the two key elements that I really want to focus in on for a builder is about building envelope performance and air tightness. Building envelope is often thought of typically thought of as a kind of a secondary element, and it's something that's really often, for the most part, only considered during construction and once you start framing. And sometimes during the design process, it's even been sacrificed in terms for cost control on a project. You can't really do that with the step code anymore, especially when you're going into step 4, 5, and passive others. So step 3, where Richmond is going to be at next year, it's a good place to start developing skills as a builder to really understand how trades coordinate with each other and really testing the sort of open lines of communication across your trades. And then understand that the less thought and care that is given to the building envelope performance, the air change, the air tightness quality on the building, the more robust the mechanical system is going to have to be, and that has its limits in high performance buildings and with high performance mechanical systems. And that sort of mentality where you're relying on your mechanical system can be pretty expensive, and it's not really a good place to be. So you really do want to put a lot of emphasis on the envelope performance. So to stay on track with the step code for builders, it's important that you strategize with your designer at the early stages, if possible. You might be able to provide some insight for, different types of building strategies and sequencing and installations. But it also does give you the chance to really understand what's coming up for construction. The next thing is reviewing drawings and details ahead of time. Make sure you understand them. Planning ahead, so make sure that the detailing that's being shown on drawings can actually be achieved. Oftentimes, a lot of designers don't really consider the reality of actually building the thing that they design. So it's important that you provide your input during that design process, so that you avoid some of those down the road costs later on. And so the next thing to consider is coordinating with your trades to make sure that critical details and junctions are identified and that they're not missed during the construction process. And the other thing is, as a builder, you really do need to make sure you're supervising the work on site, protecting the air barrier as much as possible, making sure there aren't gaps in the insulation, and just making sure people are being mindful about the work that it is that they're doing. And so to that point, with respect to the thermal performance of the building, it really does kind of come down to the concept as you head into step 4, step 5 in passive house buildings. An exterior air barrier strategy is a must when you're hitting the step 4 and step 5 passive house levels. So understanding how that works is going to be very critical to you as a builder going forward. And the continuous exterior insulation is another really important one. You see that a lot in passive houses and step 4 and step 5 buildings. So that really just helps eliminate thermal bridging and heat loss through thermal bridging on the project. And the reason why I touch on air tightness and envelope performance is because as a builder, that's something that you have the most immediate and direct control for quality during construction. So it's really important that you stay on top of that stuff. A key thing to understand is your air barrier and why it's important. Essentially, most people are aware of conceptually what continuous insulation is, but they seem a bit fuzzy on air barriers. So something to understand very simplistically is a poor air barrier makes for a leaky building. Buildings with poor air barriers essentially let a lot of heat in during the summer, let a lot of heat out during the winter. And that, that sort of scenario really becomes quite expensive for the occupant. It stresses the mechanical system, potentially to levels that it's not supposed to be performing at, and it really starts to kind of burn out the components of the house at a much earlier date than it should have been. For an air barrier, it needs to be 100% continuous to be effective, and that's different from a vapor barrier, which is really only as effective as it is continuous. The reason an exterior air barrier is the best approach is because it's generally protected from the damage that an electrician or a drywaller or a mechanical contractor may have on the building as they're going through your poly vapor barrier on the inside of the building and punching holes in for electrical and things like that. So putting the air barrier material on the outside of the building is just really a good way to try and protect the air barrier. And it also helps safeguard the building for renovation in the future. When people are pulling down walls and moving outlets and moving lights and things like that, you don't really have the owner wouldn't necessarily have to worry too much about damaging the air barrier if it's on the outside of the building. So then when you start to look at air barrier materials, you start to look at a little bit more high performance products. Ones that we often use are Siga and Proclima. They do offer sort of, especially Proclima offers a lot of full building components. That way you can sort of get all of your material from one supplier. And you know, these things will be like the house wrap goods, the air barrier tapes, sealants, self-adhered membranes, and things like that. And those are really the materials to you know, be aware of and use appropriately. And the supplier will be able to help you with the install and understanding how those things all go together. And you know, again, it's not really worth sacrificing the air barrier strategy to rely on the mechanical system, because you know, mechanical systems can be replaced over the lifespan of the house, but for the most part, you really only get one chance to get the envelope right. So it's important to make sure you get the details right. Going back to the idea of 100% continuous air barrier on the outside and identifying critical barriers, there are, you know, varying junctions around the building that you should be able to identify in section and, you know, understand that and really think in 3D as a builder and try to pull out some of those details where possible. So one of the first ones, it's a really easy one. You know, we have footing detail where you're going to be putting exterior insulation on the outside of the foundation wall, thermal break between the slab and the foundation wall, and then making sure that your vapor barrier is sealed to the foundation wall. We will often use 10 mil poly below the slab just because it's a little bit more robust and it can sort of stand up to some of the rougher site processes. And in this case, you know, again, it's really important that, you know, you're supervising and making sure rips and tears and damage to the vapor barrier below the slab are fixed before you go and pour concrete. Another sort of critical junction and making sure that, you know, trades are working together is flashing details. These things often do get missed. So having, you know, self-adhered membranes tying the top of the foundation wall to the plywood sheeting, that's going to be an important one to really reinforce the air tightness of the building. And then making sure that your exterior wrap is lapped and sealed to the top of the flashing, and making sure that's continuous and fully sealed. And you know, we often just really avoid tuck tape because it's not very sticky and it doesn't really work for the long term for this sort of application. Mid-wall areas on the building where you might have breaks in cladding, or you know, for tall walls you need breaks for ventilation. And so this concept where you place the flashing behind the rain screen and onto your exterior insulation, and then you bring a counter flashing from the plywood sheeting down to the leg, the vertical leg of the flashing, making sure again that that sort of thing is paid attention to and sealed continuously and done well. Now sometimes when it comes to roofs, you know, having a completely exterior air barrier approach can be difficult, especially for steep pitch roofs, and there are solutions for that. So one thing is to really be mindful of the transition of the exterior air barrier to an interior air barrier solution. The first thing to look at and make sure that you understand is that anytime you have a horizontal assembly like a deck or a cantilever or a roof in this case, that you're pre-stripping air barrier material on the tops of the walls before you drop your structure onto it. And that will allow you to be able to tie in your air barrier to your interior vapor barrier. And then to protect the vapor barrier on the inside, it's a good idea to frame a drop. You know, usually 5.5 inches with a 2x6 is quite sufficient for that. That'll, be able to house most pot lights that you'll find in residential construction, provide conduits for sprinkler systems, and some smaller mechanical systems for things like mini splits and that sort of stuff. So that will really limit the amount of penetrations that you have going through your interior vapor barrier on the ceiling. And then for flat roofs, this makes it really simple. If you're using an exterior air barrier approach, you can really just lap your air barrier over top of the insulated portion of the flat roof and then down the wall, and make sure it's taped and sealed. And then to create the overhang, what we try to do is avoid projections of the primary structural materials passing through the air barrier, so that you don't have to seal around each of those members. So to get around that, we'll put overframing, 2x material on top of the primary structural elements to create the overhang and slope, and that will also provide the ventilation space that's being required of the roof assembly. And for assemblies like this, it's not really necessary to drill holes in the plywood. Some people think that is necessary. It's not. Through vapor diffusion, that assembly will dry out. And this sort of assembly does have its limits. At a 12-3 pitch is probably as far as you want to go. And using 2x4 material to get a 3-foot overhang is sufficient. Anything more than that, you'll be looking at maybe doubling up your 2x material or going to 2x6. And then kind of a critical junction where that flat roof may meet an exterior upper wall. It's important to, if you're on top of your preparation for the air barrier being on the exterior, it's really just quite simply lapping the air barrier up the face of the wall, make sure you're capturing your flashing detail, making sure it's all sealed, but then also adding some of that exterior insulation into that roof cavity to make sure that you're covering your thermal bridge location. And a detail like this is where the coordination really is important, because you do have to coordinate your torch-on people, you have to coordinate your insulator, your flashing guy, and your barrier installer. For us, we often will have the exterior barrier, exterior insulation person, that scope of work handled by one installer. And sometimes the interior barrier as well. We'll get that under one installer. So looking at some of our case study projects, we have this one here. It's in Elliott Street in Vancouver. This is a step 3+ sort of home. And what you'll see in this photo is you'll see a lot of the air barrier material lapping over the tops of the walls where we have a roof meeting the wall. And this helps ensure that we're going to have a nice continuous connection between the interior air barrier and the exterior air barrier. But this is something that, again, as a builder, you have to inform your framers that anytime you're having this junction of a horizontal assembly and a vertical assembly, that they put the air barrier lap on top of the wall. And the thing that I tell our tradespeople is just, if you're unsure if you're supposed to be putting some air barrier lap on top of the wall, just put the air barrier lap there. You can have too many, that's okay, but having too little, again, if you miss the step, you have to go to an interior barrier, and that's not where you want to be. So similar to that beam detail, this is kind of what it looks like in practice. You can see we've got our insulation behind the vertical lap of the torch-on, and then the air barrier coming down in behind that. And then for this, what we would end up doing is putting a peel and stick self-adhered membrane over top of the vertical lap of the SBS, and then putting our metal flashing on that, and then bringing the exterior insulation down. And that would complete the detail. This is the project in Richmond on River Road. Partway through the construction, when we already had the framing and the torch-on complete, there was a decision to move to a high-performance building. And really, it was the aim was to sort of manage sound infiltration into the building. And one of the best ways to do that is just add mass and density to the walls into the assembly. So We added 3 inches of exterior insulation, had a deeper rate, and that'll get us to around step 4 for a project like this. And there was a lot of coordination with the glazing contractor to make sure that we had a good performance metric for our glazing. With this project, especially when you get into step 4, step 5, and passive houses, it's important to make sure that you're coordinating with your mechanical and electrical and plumbing trades to make sure you get penetrations that may need to go through that exterior barrier, that they're roughing those things in before you put your air barrier and your insulation onto the building. I can't emphasize that enough. You don't want to put in all of that work to make the building airtight and then have all your trades come in and punch holes through everything and then have to seal it all up, because guaranteed things will get missed. And then we have our project in West Van at Palmerston. This project from the very beginning was considered to be the desire was to perform at the step 5 level. And for clients, sometimes there's an incentive from the city that maybe they give you more square footage or more height, and that can often be the thing that really propels the client to want to perform at a step 5 level. From the design side, and because we have an integrated team here at VICTORERIC, we're able to work with our build side as well to make sure that what we are proposing can actually work on site. We involved the CEA very early on, really at this sort of sketch process, where we're looking at the building as a 3D mass and resolving some of those critical details, and really just trying to get a sense of where the building is at based on this design, just as a ballpark to see where it would sort of fit in the step code. And so as a builder, if you're starting and helping your client look for a designer, it's important to make sure that you're making the client aware that these sorts of processes need to be front-loaded, and it might take a bit of time for the design process to really get off the ground and really get moving towards the building permit stage.
Okay, so this is another case study. It's a passive house that we constructed and finished. We designed, built it, and finished now, then moved in. The highlight I want to talk about here is the tight air barrier. So Vancouver code air barrier is 3.5 air change. Step code 5 requires 1.0 air change. Passive house standards require 0.6 air change. In this one, we're able to actually make a record out of it, and we hit 0.16, 0.15. There was an average on there. And that's like amazing, considering that 0.6 at passive house is very tight already. How do we do that? Just really paying a lot of attention on the air barrier. You'll see photos here. This is a Sega product that we use, but you'll see this white on the left photo. I don't know if you can see my cursor, but on the left photo at the top there, we did leave extra paper to lap just in case if we need to change our air barrier strategy and go inside. So we're doing a lot of extra stuff to really protect it. And then moving on here, you'll see some really good tape application. It really just boils down to that. A lot of builders and trades buy the tape and they don't adhere it properly. They don't get the proper training. They just slap it on. But it really needs to be applied, force applied with a squeegee, done very well with a lot of attention to detail. Now, unfortunately, when we built this, we did not have many trades to choose from. It was quite a new thing. This was about 2 years ago. So we actually had our staff trained in applying this. So we took on that scope ourselves. So as a builder, that's probably something that you might have to consider. Now, more and more, as people get exposed to this, you might have more trade selection. But if you don't, maybe getting certified. BCIT has courses, trade certification courses and such. But yeah, through the photos here, basically any conduits needs to be taped well with the right product. This is down on the lower left. This is a window corner junction. You'll see the lap of the blue air barrier paper, and then the Sega tape. and there's a certain way of applying it. You can reach out to SIGA. They're very good at training. They'll come and train your team if you need to on how to do that. The middle photo, that's at the top of the roof, so that's just make sure there's a lot of overlap. And then the photo on the right is showing the window installed and seeing how everything's lapped inside so that that air barrier stays continuous. And then our final slide really is just to kind of wrap up the difference, right? So a lot of people ask, okay, from code built to step code, what does it take? Requires definitely a new approach to thinking, like I said, and Ina said. Basically, much tighter integration with your design team. Think about your construction earlier on. It's not acceptable anymore to just wait until the plans are done and then you go and build. That's the old way. You can't do that with step code. Educated guesses are very important in the beginning. So that's why this collaboration with your design team and you come along, right? The designer's going to need to know what assemblies are made very early on. So you as a builder should come in and dictate that and collaborate and help them with that, because it's going to affect your cost, it's going to affect your trade selection, it's going to affect your schedule, many things. So work as a team there. During construction, definitely more involvement with the design team. So the designer and the consultants don't just end once the permit is approved. Bring them in on site at critical times like framing and air barrier, rain screen, those times, so that they can help you along the way. They are there to help you really to maintain that. Tighter quality construction for sure. Watch your trades be like the drywaller and mechanical. They can be punching holes through your walls, and that's just not possible anymore with a tight air barrier. And like Ina's slide says, there's a point of no return where the cost of changing things and the options that you have really cross. So for high performance homes and step codes, what we found is kind of at the framing stage. So if you want to be switching horses, you start with a code built and then you want to go step code. You can probably do it relatively easy at the framing stage. Of course, the best time is right in the beginning because you have all the options. But for our River Road house, we did that at framing. We kind of switched, and it was still possible. We had to do a few extra things. It would have been much easier if it was in the beginning, like our Palmerston house, but it's possible. Step code to passive house, very similar. Mindset is the same already. You've involved your team, but going to passive house is more about tighter assemblies. Step code, you can get away with exterior insulation and air barrier and such. Passive house is specific. Sometimes the assemblies for step code just doesn't work, and you have to come up with new assemblies for passive house. And that's kind of probably the biggest difference. And then city also, depending on which city you're in. I know Vancouver, they have a separate process if you go to passive house. So know that. During construction, things to watch out for, super tight air barrier control. What you need as a builder is to dedicate someone, whether it's your site foreman or site super, and be that air barrier police. We did that for our 196 West 21st house, and it worked really well. This person's responsibility is to be coordinating with the trades. Any trades that want to puncture any holes needs to go through him first, and then they will patch up where needed. And you know, for the West 21st house, what we did was we coordinate with the mechanical plumber, and we minimize all roof penetrations down to 1, right? So that's just tightening it up even more. Foundation, insulation, and air tightness is different. It's got to be more stringent for sure. And then the point of no return is very much in the beginning. It's very hard to switch and say, okay, I want to do passive house now. It's going to cause you a lot of pain and grief.